Sometimes our demand function is not a constant. In other words, as the quantity produced changes, our price changes. We may give some discounts, or we may charge some premiums. In this case, we'll think of our demand as a function, P of x, not just a constant. Then our revenue function is given by R of x, which is x times that demand function. So before we had it as x times P, now we'll just think of it as x times P of x. But it's still the number of units multiplied by the price. So let's do a problem that involves a demand function that is not a constant. Suppose the price in dollars of a stereo system is given by P of x equals 1,000 divided by x squared plus 1,000, where x represents the demand of the product and presumably is the number of stereo systems. Find the marginal revenue when the demand is 10 stereo systems. So we're going to take R of x, and to get that, we're going to take x times P of x, or x times the quantity, 1,000 over x squared plus 1,000. Before we go any farther, let's try and simplify that. So I'm going to go ahead and distribute the x onto each one of the terms in parentheses. So x times 1,000 over x squared, well, an x is going to cancel, leaving us with 1,000 over x. X times 1,000 is 1,000x. So our new revenue function is 1,000 over x plus 1,000x. And to get the marginal revenue, we're going to need to go ahead and take the derivative and then plug 10 into it and figure out what that means. I'm going to write down my revenue function here and take the derivative. But before I can take the derivative, I haven't shown you how to do division. But remember, an x on the bottom is the same as x to the minus 1, so 1,000 over x is the same as 1,000 x to the minus 1. Now that's of the form x to the n, and I can go ahead and use my power rule. And 1,000x is the same as 1,000 x to the 1. I can do the power rule on that also. So when I apply my power rule, remember the power comes down in front, so I get 1,000 times minus 1, or minus 1,000, and then I subtract 1 from the power. Minus 1 take away 1 is minus 2. When I take that x to the first, and I take the derivative of that, I get 1. 1 times the 1,000 gives me 1,000. My derivative is minus 1,000, x to the minus 2, plus 1,000. I can rewrite that by putting the x to the minus 2 back downstairs, and in that case I get minus 1,000 over x squared plus 1,000. To figure out our marginal revenue, now I'm going to need to go ahead and put 10 into this function. So r prime of 10 is going to be minus 1,000 over 10 squared, or 100, plus 1,000. When I simplify that, I get 990. So the marginal revenue to produce 10 systems is $990 per system. Remember, we're doing slopes here, so slope on this will be dollars per system. This means that to produce and sell the 11th system, one more, is going to yield us approximately $990 in revenue. Now let's take a cost function and a revenue function and put them together and then try and figure out what the corresponding profit's going to be. So an analyst has found that a company's costs and revenues in dollars for one product are given, or for X products that should be, is C of X equals 2X and R of X equals 6X minus X squared over 1,000, where X is the number of items produced. What value of X makes the marginal profit equal to 0? So I'm asking you about the marginal profit. So what we're going to need to do first is get the profit function by subtracting revenue minus cost. Once I've done that, I can take its derivative and set it equal to 0. So we need to read this very carefully to know exactly what we need to do. So we'll take P of x equals R of x minus C of x, revenue minus cost. The revenue function was 6x minus x squared over 1,000, and we're going to subtract off our cost function, 2x. When we simplify that, the 6x minus 2x will give us 4x, and the minus x squared over 1,000 term comes along for the ride. So there's our profit function. Now we need to take its derivative to get the marginal profit. So we've got P of x equals 4x minus x squared over 1,000. I'm going to take the derivative of that. And when I take the derivative of the 4x, I get 4. The derivative of x squared over 1,000, that one sometimes frustrates students a little bit. But think of x squared over 1,000 as simply 1 over 1,000 times x squared. The 1 over 1,000 is a constant, so take the derivative of x squared, which is 2x, then multiply back through by that 1 over 1,000, and that gives us 2x over 1,000. So we now have our marginal profit function, and we need to set that equal to 0 and solve it for x. So I'm going to go ahead and move the 2x over 1,000 to the other side. When I do that, I get 4 equals 2x over 1,000. And in order to solve that, I'm going to clear out my fractions by multiplying both sides by 1,000. That leaves me with 4,000 equals 2x. Now I can divide both sides by 2. And I'm left with x equals 2,000. Marginal profit is equal to 0 at x equals 2,000 units. Now let's take that marginal profit and let's go ahead and find the marginal profit at a level of production of 1,900 and 2,100. So all that's asking me to do is to plug those numbers in. So when I go ahead and plug in 1,900 into this derivative, I get 4 minus 2 times 1,900 over 1,000. 2 times 1,900 over 1,000 is 3.8. So 4 minus 3.8 gives me 0.2. So what this means is producing an additional item at this production level will yield an increase in profit of $0.20 or 20 cents. So if I decide to increase my production here, I'm going to make more money. If I go ahead and look at P prime of 2,100, now I get 4 minus 2 times 2,100 over 1,000. And 2 times 2,100 over 1,000 is 4.2. So 4 minus 4.2 gives me minus 0.2. This means that an additional item produced will yield a decrease because of the negative sign in profit of 20 cents. When we had the production level of 2,000, our marginal profit was 0. When I had a production level of 1,900, our marginal profit was positive, telling me that if I increased my production, I'd make more money. And if I did a marginal profit at 2,100, increasing production there would mean I'd lose money. So where do you think I'm going to operate my business? If I'm operating at 1,900, I'm probably going to ramp up my production because I make more money when I do that. If I'm beyond that point at 2,100, I'm going to lose money when I increase production. The place where I want to operate it was at that place where the marginal profit was 0, because there, increasing my production didn't change the profit at all. It stayed flat because P prime of 2,000 was equal to 0.